Good day, welcome to this episode of Physics 191. We are considering the topic Measurements and Graphical Methods of Module 1, Unit 1. As a student of physics, most of your activities will involve observing phenomena and measuring some fundamental physical quantities like time, mass, length, temperature, and so on. This unit will introduce you to the graphical methods for representing observations, different types of graphs, and how to use them to make relevant deductions. And at the end of this unit, you should be able to identify dependent and independent variables. Also, you should be able to show how the independent and the dependent variables are related linearly. Then the third thing is that you should be able to show how the independent and the dependent variables are related non-linearly. Then also you should be able to deduce the valuable information from the graphs through the use of slopes. And finally, you should be able to deduce valuable information from the graphs through the use of slopes and intercepts. Now, the graphical methods. In physics experiments, we are interested in understanding how two variables are related. These two variables mentioned are termed independent variables and dependent variables. For example, if you have two quantities, A and B, and if quantity A values depend on the values of quantity B, then you can say that B is the independent variable while A is the dependent variable. Now, what is a graph? A graph is a pictorial way of showing how these two physical quantities, either fundamental or derived quantities, how they are related. The essential features of a graph are the two varying quantities called the variables. Now, the physical quantity which is made to vary at will is called the dependent variable, and the other physical quantity which changes as a result of this change is known as dependent variable. Now, there are important features of the experimental observation which can be seen at a glance without difficulties. These are these variables if they are illustrated by a suitable graph. The graph can be either straight or curved. Now, this will lead to types of graphs. We have two basic types of graphs. We have the linear graph, which we call the straight line graphs. Now, the straight line graph represents the simplest form of the relationship between two variables. Where the details of the relationship are not known, they can be completely determined by making only two measurements. And these two measurements are the slope and the intercept. Now, if two variables x and y are plotted on a straight line, the equation of the line is given as y equals to mx plus c, where m and c are constants, and m is the slope of the graph, which is also called the gradient, and c is the intercept. This sketch is to be used to explain how to determine slope and intercept on a straight line graph. You see, we have y2, y1, x2, x1. How did we obtain this? On your line of best fit of your graph, make a right angle triangle. On the right angle triangle, trace 2 points, the highest points on the vertical axis, the lowest on the horizontal axis, that's your y2 and y1, and trace that of the horizontal axis too, x2 and x1. The change in y divided by change in x give you the slope as illustrated in this equation. Now, the curved graph, which is the non-linear graphs, the more curved the graph is, the more the points needed to draw the curve accurately. Now, unfortunately, these curved graphs often provide very little information about the relationship between the variables plotted. In certain cases, the tangent to the curve at some points on it provides useful information. So it is therefore needed, and it is therefore important to be able to draw tangents to a curve. And I want to show how you can draw tangents to a curve if you have a curve graph. Look at this. This is a curve. To produce tangent to this curve, make a straight line that passes through any of the points, that touches any of the parts of the curve. Then this, your tangent has been formed. Draw a right angle triangle to it to determine the slope as illustrated earlier. In summary, so far you have learned the significance of graphs in physics practicals, and you have also learned that a straight line graph gives a linear relationship between the two variables in question. You have also learned the slope of the graph to be determined by the ratio of the change in the dependent variable to the change in the independent variable. And finally, you have learned how to determine the slope of a curved, which is also a non-linear graph at a given point. That is the end of this unit titled Measurements and Graphical Methods. Thank you.